Today we are going to look at a new conic section shape called a hyperbola. A hyperbola is considered the set of points in a plane such that the difference of the distances from two fixed points, called foci, is constant. Recall from yesterday the definition for an ellipse was when the sum of the distances to the foci was constant. Here is the basic shape of the hyperbola. It almost looks like two sort of parabola shapes together. We've got the center of our hyperbola, and these points here are called the vertices. And this time, the points that are on the outside, these are the foci, the focus points. The transverse axis is the axis in which the vertices and the foci are on. We can see that the hyperbola can also be oriented this way. Here is the center. This time the vertices are on the y-axis and the foci are also on the y-axis. I also want to point out the general form of the equation for a hyperbola. Let's see how it is different from the formula for an ellipse. The ellipse involves a plus sign, and the hyperbola is a minus sign. The other difference is that the x squared could be in front, resulting in this shape. The y squared in front is going to result in the other shape. So really whatever variable is in front indicates the axis that is the transverse axis containing the vertices and the foci. The way that I sort of think about this, the way that I remember that the x squared comes first is I think about what that shape looks like. If I kind of draw that off to the side, it kind of reminds me of an X. If there was no distance in between the two, it would kind of look like it was an X, and so that's how I remember that the x squared comes first. Alright, so here again we have listed the standard forms of the equations of a hyperbola. Notice how both of these are centered at the origin. And another difference from a hyperbola to an ellipse is that a squared is not necessarily greater than b squared. The equation to find the focus points, the foci, is similar to the equation for an ellipse, but this time we're doing c squared equals a squared plus b squared. C still represents the distance from the center to a focus point. All right, and one last feature of the hyperbola graph is that we have asymptotes. These are these dotted diagonal lines, and the equations of the asymptote is based on, if we kind of think about the y equals mx plus b, general form for a linear equation. If it's centered at 0, 0, the asymptote passes through 0, 0, so that is the y-intercept. And then to get the slope, we're going to think about doing rise over run. So if we do rise over run, we see this change in the y direction is b, that's the rise. And then the distance, the change in the x direction here is a, so that is the run. So the rise over the run is b over a for this first one. So that's the positive slope. It looks like an increasing line. The other line over here that has a negative slope is going to be this equation down here, minus b over a. We have slightly different equations when it's oriented the opposite way. We just always want to think about rise over run. If you have your box drawn and you can just visually count the squares in your box, it'll be very easy to determine your slope for the equations for your asymptote lines.